KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
Next concept in applications of derivatives is increasing and decreasing functions. Increasing and decreasing functions. Okay. I will discuss with an example. Okay. Consider the function f of x is equal to x square. Okay. F of x is equal to x square or y is equal to x square is upward parabola. We know this. Okay. Now to draw the graph of f of x equal to x square. Okay. Now when x is -3 square 9, when x is -2 square 4, when x is -1 1, when x is 0 0, when x is 1 1, when x is 2 square 4, when x is 3 square 9. Okay. Now this is the graph. Okay. This is the graph of y is equal to x square. Rough graph of y is equal to x square. Okay. Y is equal to x square. Okay. Now if you observe, now right side of origin, okay, right side of origin, when x value increases, f of x value increases very fast. Suppose x is 1, f of x is 1 square. When x is 2, f of x is 2 square is 4. When x is 3 square 9. When x is 4 square 16 and so on. Okay. So what we can observe here, right side of origin. Okay. When you move from left to right, function y is equal to x square or f of x is equal to x square increases very fast. Okay. Increases no, as we move from left to right. Okay. 0 to infinity, y is equal to x square increases very fast. Okay. So height of the graph is increasing, no, continuously increasing. Okay. Increasing very fast. Okay. So this is increasing function. Y is equal to x square is increasing function for x greater than 0. Okay. For x greater than 0, y is equal to x square is increasing function. Now left side of origin, negative side. Okay. Now as you move from left to right, graph coming downwards. Suppose when x is equal to -3, f of x is what? 9. When x is equal to -2, f of x is what? -2 square 4. When x is equal to -1, f of x equal to -1 square is 1. So as you move from left to right, graph continuously decreasing. Okay. Continuously decreasing. Okay. So y is equal to x square or f of x equal to x square is increasing function for x positive, decreasing function for x negative. Okay. My increasing function means as you move from left to right, graph has to increase. Decreasing function means as you move from left to right, graph has to decrease. Now y is equal to x square or f of x equal to x square is increasing function for x positive. Okay. F of x equal to x square is a decreasing function for x negative. Okay. Now what about f of x equal to x square for x belongs to R? For x belongs to R, it is neither increasing nor decreasing function. Okay. F of x equal to x square, if x belongs to R, it is neither increasing nor decreasing, because some portion it is decreasing, some portion it is increasing. So it is neither increasing nor decreasing for x belongs to R. F of x equal to x square is increasing function for x positive. F of x equal to x square is a decreasing function for x negative. Okay, f of x equal to x square is neither increasing nor decreasing for x belongs to R. Okay, where we are considering x, that is also important. Okay, my increasing function means as you move from left to right, graph has to increase. Decreasing function means as you move from left to right, graph has to decrease. Okay, now one more definition will give. Let I be an open interval contained in the domain of real valued function f. Okay, I be an open interval in the domain of real valued function f. Okay, then f is said to be increasing on I. Okay, increasing function if x1 less than x2 in I, that implies f of x1 is less than or equal to f of x2 for every x1 x2 belongs to I. Means if you consider any two arbitrary points in the interval such that x1 is less than x2 and in I, okay, x1 is less than x2 in I, that implies f of x1 is less than or equal to f of x2, then it is a increasing function. This has to be true for every x1 x2 belongs to I. Now for example, f of x equal to x square, f of x equal to x square. Now here 1 comma 2 belongs to this interval, 0 to infinity. Okay, 0 to infinity. Now 1 less than 2, 1 less than 2, 1 less than 2 in I, and f of 1 is how much? F of 1 is 1, f of 2 is how much? 4. Okay, f of 1 is less than or equal to f of 2. Okay, this is true for every x1 x2 belongs to I. Now in 0 to infinity, any two numbers you take, any two numbers you take, 1 3 if you consider, 1 less than 3, f of 1 is less than f of 3. Okay, it is a increasing function. Means if x1 is less than x2 and f of x1 is less than or equal to f of x2, function is increasing function. Function is increasing function. Okay, strictly increasing means no inequality. Strictly increasing means no inequality. Simply if x1 less than x2 in I, f of x1 less than f of x2 for every x1 comma x2 belongs to I. Okay, increasing means inequality can be there. Okay, x1 less than x2 in I, that implies f of x1 is less than or equal to f of x2. Okay, for every x1 x2 belongs to I. This is increasing condition. Strictly increasing means no inequality, simply x1 less than x2, that implies f of x1 is less than f of x2 for every x1 x2 belongs to I. That is strictly increasing function. Okay, simple condition is if you consider two elements x1 less than x2 in I, if f of x1 is less than f of x2 or f of x1 is less than or equal to f of x2, increasing function. Okay, decreasing means x1 less than x2 in I, x1 less than x2 in I, but f of x1 greater than or equal to f of x2 for every x1 x2 belongs to I, then it is a decreasing function. Decreasing function. Okay, x1 less than x2 implies f of x1 greater than or equal to f of x2, it is decreasing function. If x1 less than x2, that implies f of x1 greater than or equal to f of x1 greater than f of x2, it is strictly decreasing. Okay, now example, now here f of x equal to x square in the interval minus infinity to 0 if you consider. Okay, minus 3 less than minus 1, no? Minus 3 less than minus 1, but f of minus 3, f of minus 3 is how much? 9, f of minus 1 is how much? 1, 9 greater than or equal to 1, 9 greater than 1. Okay, so it is a decreasing function, decreasing function. Okay, my increasing function means simply x1 less than x2, prove f of x1 less than or equal to f of x2. Strictly increasing means no inequality, f of x1 less than x2, that implies f of x1 less than f of x2. Okay, strictly increasing condition. Okay, decreasing x1 less than x2, that implies f of x1 greater than or equal to f of x2, decreasing. Okay, x1 less than x2, that implies f of x1 greater than f of x2, that is strictly decreasing. Okay, now f of x equal to x square, when interval is 0 to infinity, increasing function, when interval is minus infinity to 0, decreasing function, when interval x belongs to minus infinity to plus infinity, neither increasing nor decreasing function. Okay, But some examples, now this is increasing function, okay, increasing function, increasing stationary and increasing. Now this is continuously increasing, okay, as you move from left to right, graph is moving upwards. Here also same thing, no, as you move from left to right, graph moving upwards, okay, increasing function. This is increasing, this is strictly increasing. Now similarly, this is decreasing as you move from left to right, graph coming downwards, okay, decreasing. Now here stationary, this is decreasing. Now here strictly decreasing as you move from left to right, graph coming downwards, okay. Conditions wise is x1 less than x2, that implies f of x1 less than or equal to f of x2 increasing, okay. x1 less than x2, f of x1 less than f of x2 strictly increasing. Decreasing means x1 less than x2, if f of x1 greater than or equal to f of x2, decreasing, okay. x1 less than x2, f of x greater than f of x2, strictly decreasing, okay. Now here this is example of increasing, strictly increasing. This is a decreasing, strictly decreasing, okay. But this graph is neither increasing nor decreasing graph. This graph is neither increasing nor decreasing graph, okay. In some interval it is increasing, some interval it is decreasing, okay, neither increasing nor decreasing graph, okay. Now I will give examples for increasing, decreasing, okay. Now y is equal to x cube graph, okay. Rough graph is this one. As you move from left to right, graph moving upwards, okay. Y is equal to x cube is a strictly increasing curve, strictly increasing curve. Y is equal to x cube is a strictly increasing curve. Now you can check also, okay. You take any two arbitrary elements, okay. Now for example -2 and 3, okay. -2 cube is how much? -8. 3 cube is how much? 27. Okay, -2 less than 3, f of -2 is less than f of 3. It is strictly increasing function. Okay, similarly, y is equal to -x. Y is equal to -x is strictly decreasing curve. Now as you move from left to right, graph coming downwards, it is a strictly decreasing curve. Y is equal to x cube is strictly increasing curve, y is equal to -x is strictly decreasing curve, okay. Next, here next example, f of x is equal to sin x. F of x equal to sin x. I draw graph between -pi to +pi, okay. Sin x graph -pi to +pi. Now what you can observe, -pi to +pi, sin x is neither increasing nor decreasing function. -pi to pi, f of x equal to sin x is neither increasing nor decreasing function. Now if you observe carefully, -pi/2 to +pi/2, -pi/2 to +pi/2, sin x is a increasing function. -pi/2 to +pi/2, it is a sin x is a increasing function. And pi/2 to pi, it is decreasing function. -pi to -pi/2 is also decreasing function. So f of x equal to sin x is increasing in -pi/2 to +pi/2. F of x equal to sin x is decreasing in -pi to -pi/2 and pi/2 to pi, okay. -pi to -pi/2 and pi/2 to pi, okay. So f of x equal to sin x is increasing function in -pi/2 to +pi/2, decreasing function in -pi to -pi/2 and pi/2 to pi, okay. Now overall if you consider f of x equal to sin x in -pi to +pi, it is neither increasing nor decreasing function, okay. How to check whether given function is increasing function or decreasing function, okay. Simply if f of x1 less than x2 consider, if you are able to prove that f of x1 less than or equal to f of x2 increasing, okay, and x1 less than x2, if you are able to prove that f of x1 greater than or equal to f of x2 decreasing function, okay. I will discuss with an example. Example 7, show that the function f of x equal to 7x minus 3 is strictly increasing on R. Now strictly increasing on R means what we have to prove? Consider any two arbitrary elements x1, x2 belongs to R such that f of x1 less than x2. Prove that f of x1 is less than f of x2, then f is strictly increasing on R. Okay, now let x1 comma x2 belongs to R, means x1 x2 are two real numbers such that x1 is less than x2. x1 is less than x2. x1 x2 be any two real numbers satisfying the property that x1 is smaller than x2. Now as x1 less than x2, if you multiply 7 on both sides, inequality won't change, no. So 7x1 is less than 7x2, 7x1 is less than 7x2. And if you subtract 3 on both sides, inequality remains same. So 7x1 minus 3 less than 7x2 minus 3. Okay, but 7x1 minus 3 is nothing but f of x1. 7x2 minus 3 is nothing but f of x2. So f of x1 is less than f of x2. Are we able to prove that? Now we consider x1, x2 be two real numbers satisfying the property, satisfying the condition x1 is less than x2. We are choosing two real numbers such that x1 is less than x2. Okay. Now x1 is less than x2, multiply 7 on both sides, inequality won't changes. So 7x1 is less than 7x2. Okay. Now subtract 3 on both sides. Inequality remains same, 7x1 minus 3 less than 7x2 minus 3. Okay. This is nothing but f of x1. This is nothing but f of x2. Okay. Because f of x is 7x minus 3, f of x1 is 7x1 minus 3, f of x2 is 7x2 minus 3. Okay. So f of x1 less than f of x1 less than f of x2. Okay. Now we consider x1 is less than x2. Prove that f of x1 is less than f of x2, means f is a strictly increasing function on R. Okay. Next. The next theorem, let f be a continuous function on closed interval AB and differentiable on open interval AB. Then f is increasing function in closed interval AB if f dash of x is greater than 0 for every x belongs to open interval AB. Okay. So here what is given, f is a continuous function on closed interval AB, differentiable on open interval AB. Okay. Then f is increasing function if f dash of x is greater than 0 for every x belongs to AB. What is given here, f is continuous on closed interval AB and differentiable on open interval AB. Okay. If f is continuous and differentiable, then mean value theorem, differentiation we discussed, by mean value theorem there exists a point, okay, C such that f dash of C is equal to f of x2 minus f of x1 upon x2 minus x1, okay, where x1 x2 are any two arbitrary points in closed interval AB such that x1 is less than x2. Okay. First one I am proving, second and third I will explain just. Okay. What is given, f is a continuous function on closed interval AB, f is a differentiable function on open interval AB, then f is increasing in closed interval AB if f dash of x is greater than 0 for every x belongs to open interval A comma B. Okay. What is given, f is continuous on closed interval AB, f is differentiable on open interval AB. Okay. Now by mean value theorem I will consider first of all x1 x2 be two elements in closed interval AB such that x1 is less than x2. x1 is less than x2. Okay. Then by mean value theorem there exists a point C between A1 and A2, C between x1 and x2 such that f dash of C is equal to f of x2 minus f of x1 upon x2 minus x1. F of x2 minus f of x1 upon x2 minus x1 is equal to f dash of C. This is we discussed while discussing mean value theorems. Okay. So if we cross multiply x2 minus x1, so what we get, f of x2 minus f of x1 is equal to f dash of C into x2 minus x1. What we consider, x1 is less than x2, x1 is less than x2 means x1 is smaller than x2, then x2 minus x1 is positive, no? So this is positive, this is positive. Okay. Now if f dash of C positive, okay, that is given, no? As f dash of C positive, this is positive and this is positive, so positive into positive is positive, so right hand side is positive. So f of x2 minus f of x1 is positive, f of x2 minus f of x1 is positive. Now f of x2 minus f of x1 is positive means f of x1 is f of x2 is greater than f of x1. Simply write this term this side. So f of x2 greater than f of x1. F of x2 greater than f of x1. So f of x2 greater than f of x1 means f of x1 is less than f of x2. F of x1 is less than f of x2. So what we consider here, x1 less than x2. What we proved here, f of x1 is less than f of x2. Okay. What we have, x1 is less than x2 implies f of x1 is less than f of x2 for every x1 x2 belongs to a comma b. For every x1 x2 belongs to a comma b. Okay. Now what we can say, f is a increasing function in closed interval a comma b. F is a increasing function in closed interval a comma b. Okay. Here f is a continuous in closed interval a comma b, differentiable in an open interval a comma b, then f is an increasing function if f dash of x is positive for every x belongs to open interval a comma b. Okay. How we proved? x1 x2 belongs to ab such that x1 is less than x2. Okay. Then by mean value theorem, there exists a point between x1 and x2 such that by mean value theorem f dash of c is equal to f of x2 minus f of x1 upon x2 minus x1. Okay. Now write x2 minus x1 other side. So what we have, f of x2 minus f of x1 is equal to f dash of c into x2 minus x1. Okay. Now this is positive, f dash of c is also positive given. Okay. So what we have, f of x2 minus f of x1 is greater than 0, f of x2 is greater than f of x1. Okay. So f of x2 greater than f of x1. What we consider, x1 is less than x2 and we proved that f of x1 is less than f of x2. Okay. So f is increasing function in closed interval a comma b. Similarly we can prove second one, third one also. What is second one? B. F is decreasing in closed interval ab if f dash of x is less than 0 for every x belongs to open interval ab. Okay. F is a constant function in closed interval ab if f dash of x is equal to 0 for every point in closed open interval ab. So to prove f is increasing function, it is enough if you are able to prove that f dash of x is positive. To prove f is a decreasing function in closed interval ab, simply prove that f dash of x is less than 0 in open interval a comma b. Okay. To prove f is a constant function, simply prove f dash of x equal to 0 for every point of a comma b. Okay. Now I will repeat once again. To prove a function is an increasing function, simply prove that f dash of x is greater than 0 in open interval a comma b. To prove f is a decreasing function, simply prove f dash of x is less than 0 for x belongs to a comma b. Okay. F is constant function, what will prove? F dash of x equal to 0 for x belongs to open interval a comma b. Okay. So what we have here, f is increasing function in a comma b if f dash of x is positive for each x belongs to a comma b. F is decreasing in open interval a comma b if f dash of x is less than 0 for each x belongs to open interval a comma b. Okay. That's it. These two are important, and if function f will be increasing or decreasing in R if it is so in every interval of R. Okay. Simply to prove f is increasing, prove that f dash of x is greater than 0. To prove f is decreasing, prove f dash of x is less than 0. Okay. We will discuss problems. Example 8. Show that the function f is given by f of x equal to x cube minus 3x square plus 4x. X belongs to R, strictly increasing in R. Means it is throughout increasing function. This is throughout increasing function. Okay. Now to prove this is an increasing function, what we have to prove? We have to prove that f dash of x is positive for every real number. F dash of x is positive for every real number. Okay. So f of x is x cube minus 3x square plus 4x. F dash of x is equal to derivative x cube derivative 3x square minus 3x square derivative minus 6x plus 4x derivative 4. Okay. X cube derivative 3x square minus 3 into x square derivative 2x. So 2 into minus 3 minus 6x plus 4x derivative 4. Okay. Now overall, if you observe here, now 4 I will write as 3 plus 1. From first 3 terms I will take 3 common. So 3 into x square minus 2x plus 1 plus 1. Okay. So 3 into x square minus 2x plus 1, what we can write? X minus 1 whole square. So 3 into x minus 1 whole square plus 1. what I did here ma, what is given function f of x equal to x cube minus 3x square plus 4x. Okay, to prove that function is increasing function, we have to prove that f dash of x is positive. Okay, f dash of x is equal to x cube derivative 3x square minus 3 into x square derivative 2x, so minus 6x plus 4x derivative 4. Okay, this 4 I will write as 3 plus 1. So what we get, 3x square minus 6x plus 3 plus 1. So first 3 terms take 3 common, so 3 into x square minus 2x plus 1 plus 1. Now x square minus 2x plus 1 is x minus 1 whole square, no? So 3 into x minus 1 whole square plus 1. Okay, so but this is x minus 1 whole square is always greater than or equal to 0. Greater than or equal to 0 multiplied by 3 is obviously greater than or equal to 0. Okay, greater than or equal to 0 plus 1 is always greater than 1, greater than or equal to 1. Okay, this is always greater than or equal to means obviously greater than 0. So f dash of x is greater than 0 for every real number. Okay, so f is strictly increasing function on R. Strictly increasing function on R. Okay, but to prove that function is increasing function, prove that f dash of x is greater than 0. To prove function is decreasing function, prove f dash of x is less than 0. Okay, now example 9. Prove that the function given by f of x equal to cos x. What is given function? Cos x, f of x equal to cos x. Decreasing in 0 to pi, we have to prove this function is decreasing in 0 to pi and increasing in pi to 2 pi and neither increasing nor decreasing in 0 to 2 pi. Okay, now one way you can see is if you observe graph of cos x. Okay, cos 0 is 1 ma, cos pi by 2 is 0, cos pi is minus 1. So as you move from left to right, 0 to pi, graph comes down. Okay, as you move from left to right, graph comes downwards, decreasing function. Now if you observe from pi to 2 pi, cos pi is minus 1, cos 3 pi by 2 is 0, cos 2 pi is 1. So as you move from pi to 2 pi, cos x graph increases. So 0 to pi decreasing, pi to 2 pi increasing. Okay, now 0 to 2 pi neither increasing nor decreasing, because in 0 to pi it is decreasing and pi to 2 pi increasing. Okay, in some interval it is decreasing, some interval it is increasing and decreasing. Okay, 0 to pi it is decreasing, pi to 2 pi increasing. So in 0 to 2 pi it is neither increasing nor decreasing. Okay, what is f of x? F of x is cos x. So to prove function is increasing, what will prove? F dash of x is greater than 0. To prove function is decreasing, we prove that f dash of x is less than 0. Now given function f of x is cos x, f dash of x is what? Minus sin x. Derivative of cos x is minus sin x. Now first question, decreasing in the interval 0 to pi we have to show. To show this we have to show that f dash of x is negative in 0 to pi. That is what we have to show. Now what we got? F dash of x is equal to minus sin x. Minus sin x. 0 to pi means first quadrant and second quadrant. In first quadrant and second quadrant, sin is positive. Okay, 0 to pi, sin x is positive. So sin x positive. Positive quantity multiplied by negative sign is what? Negative. Okay, so for each x belongs to 0 to pi, sin x is positive. We have f dash of x is negative, because sin x is positive. Positive quantity multiplied by minus sign is negative. Sin x is positive, minus sin x is negative, no? So f dash of x is negative. So f dash of x negative means f is decreasing function. So f is strictly decreasing in 0 to pi. F is strictly decreasing in 0 to pi. Okay, next. F of x is cos x, f dash of x is minus sin x. Now pi to 2 pi. Pi to 2 pi means third quadrant and fourth quadrant. In third quadrant and fourth quadrant, sin is negative. Sin is negative. Third quadrant and fourth quadrant, sin x is negative. So minus sin x is positive. Okay, sin x is negative. Sin x in third quadrant and fourth quadrant, x belongs to pi to 2 pi. Sin x is negative. Sin x is negative. Then minus sin x is positive, means f dash of x is positive. So f dash of x is positive. So f is strictly increasing in pi to 2 pi. F is strictly increasing in pi to 2 pi. Okay. Now from a and b, we can say that function is neither increasing nor decreasing in 0 to 2 pi. Okay. Next question. Okay. Now here note it is written, since the function is continuous at the endpoints 0, pi, 2 pi. So by theorem 1, f is increasing in pi to 2 pi and decreasing in 0 to pi. Okay, that is we can write. Okay. Next, example 10. Find the intervals in which the function given by f of x equal to x square minus 4x plus 6 is strictly increasing, strictly decreasing. Now we have to check where the function f of x is equal to x square minus 4x plus 6 is increasing and decreasing. So what is given function? F of x equal to x square minus 4x plus 6. Now function is increasing function wherever f dash of x is positive. Function is decreasing function wherever f dash of x is negative. Okay. So first find f dash of x. F of x equal to x square minus 4x plus 6. F dash of x is equal to what? 2x minus 4. Okay, 2x minus 4. Okay. Now where it is positive, where it is negative, first equate to 0. F dash of x equate to 0. Equate to 0, what we get? 2x minus 4 equal to 0 is x is equal to 2. Okay. So f dash of x is 0 at 2. So entire number line is divided in two parts, minus infinity to 2 and 2 to infinity. So in one interval it is positive, one interval it is negative. We have to check where it is positive, where it is negative. Okay. Now if you consider any number below 2, any number below 2, minus infinity to 2, any number you choose, better easy number is 0. Okay. If you choose x value as 0, so x0 means f dash of x is equal to what? Minus 4. So f dash of x is negative in the interval minus infinity to 2. F dash of x is negative in the interval minus infinity to 2. So as f dash of x is negative in the interval minus infinity to 2, f is strictly decreasing in the interval minus infinity to 2. F is strictly decreasing in the interval minus infinity to 2. Okay. Now if you consider any number above 2, consider 3. Okay. If you write 3 here, 3 to 6 minus 4, 2 positive. So f dash of x is positive for any number between 2 to infinity. Okay. F dash of x is positive for every number between 2 to infinity. So in the interval 2 to infinity, f dash of x is greater than 0. Okay. So f dash of x is positive means f of x is increasing function. F of x is increasing function in the interval 2 to infinity. F of x is increasing function in the interval 2 to infinity. Now here we have only 1 0 for f dash of x. In some questions we get more than 1 0. Okay. Like x is equal to minus 2, x equal to 0, x equal to 2, something like this will get. We have to divide in the intervals. In which interval f dash of x is positive, there f of x is increasing. Okay. In which interval f dash of x is negative, there f is decreasing function. Okay. Okay, we will continue remaining problems in next class. Thank you.